Hello everyone. Today we will be solving the longest consecutive sequence problem. Given an unsorted array of integer nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in O(n) time. So here we are given an array of integers. We just have to find the longest consecutive element sequence. First of all, we just need to know what are the different consecutive sequences that are available in this integer array. We could argue 100 is a valid consecutive element sequence as it contains only one element. Similarly, we could say for 200, basically all the arrays which contain single elements, they are valid consecutive elements. What I can say that is the longest would be 1, 2, 3, 4, right? This is the longest valid consecutive sequence. So the output would be 4, which is coming from this array. There could be some duplicate elements also in the array, such as in this example. We just have to ignore the duplicate elements and the output would be 4, which is also again coming from a valid consecutive sequence, which is 2, 3, 4, 5, which starts from 2. So the brute force approach that you could think is you basically start from each element and think that number as the starting point of reference for the consecutive sequence. So when you come to 2, just think of this 2 as a first element of the sequence. Then you check for all the elements that comes after 2. So basically you check 3 if it's present in the array or not, then 4, then 5. You keep on doing this until you found the next number, right? For example, in this case 2, you will search 3 if it exists in the array. If it exists, you then check 4. If it exists, then you check 5, and you count what is the longest count that you have seen starting from 2. Then you consider 0 as the starting element of the sequence. Then you again check for 1. Since 1 doesn't exist, you break the loop. So if you understand the intuition, I'll just show you how you will be doing it right here. So basically, you will be blindly treat every single number in the array as if it is the starting point of a sequence. For each number, you just scan the entire array to check if the next number exists. So for 100, you will check if 101 exists, and if it exists, you will check 102. You will keep on doing this until the sequence breaks, right? So for in this example, you will just check if you will just consider 100 as the starting element. You will check if 101 exists. If it doesn't exist, you then go to the next number. You treat this number as a starting point of a sequence. You check 5 if it exists. It doesn't exist, you go to 200. You treat this 200 as a starting point of sequence. You just consider the next number 201 if it exists or not. If it doesn't exist, you treat 1 as the starting point of a sequence. When you take the starting point of the sequence as 1, you check for the next number if it exists or not in this array, which is 2, and it exists. Then you check for the next number 3. If it exists, then you check for the number 4. So what do you think will be the time complexity of this solution? So you will treat every number as a starting point of a sequence, so basically n, and then you will linear search. Then you will do a linear scan for each of the next probable number, right? Let's say when you are at 1, what could be the how many linear scans you will be doing, right? Let's say the longest sequence is of length L. So basically you will be doing L linear scan, right? And each linear scan takes of n time. So the time complexity would be of n cross L cross n, and at worst the L could be n, right? The length of the longest sequence could be n. So the complexity becomes of n cube. And what's the space complexity? It will be constant time since you are not using any space. Now, can you do better than this? Of course, you can do better than this. If you have to reduce the time, you have to increase your space complexity, right? So, how you can improve it, right? Is there any other solution? Yes, there is. What if you could just sort the array, right? So then all the consecutive numbers sit right next to each other. What will happen in that case? So let's say given this array, you just sort this array. So this array becomes like this, right? So when you sort the array, all the consecutive numbers are just sitting right next to each other, right? Then you just walk through the sorted array, right? Starting from left and all going to the right, comparing the current number with the previous number. If the numbers are consecutive, we increase our sequence count. If they are duplicates, we simply skip them. So let's say you are at this index and the current number is 2. If you compare it with the previous number, you will just check, yes, are they consecutive? Yes, they are consecutive. So you just increase the counter that the current sequence is of length 2, which includes elements 1 and 2, right? You then go to the next number, you just check if the current number, which is 3, is consecutive to the previous number. Yeah, it is. So you just increase the counter. So the current sequence is 1, 2, and 3. You go to the next index, which is 4. You just check if this is consecutive. Yeah, it's consecutive to its neighbor. So just increase the counter, right? So the counter would be in this case equal to 4. Now when you come to the this number, which is 100, you see this number is not part of the previous sequence, which is 1, 2, 3, and 4. So the chain is broken here. So what you do is you just compare what's the counter so far. It's 4. So you just set the max length. You just store the max length as 4. You just reset your counter to 1 and the sequence again starts from 100, right? Then you go 200. If 200 is consecutive to 100, you do the same. You just compare if the max length you need to update the max length or not. But in this case, 200 is not consecutive, right? So there is again some gap in here. So you just again set the counter to 1 and your sequence starts from here, right? So what's the pseudocode for this one? So if you check here, first there is an edge case. You just check if the array is empty or not. If it's empty, then just return 0. There is no consecutive elements, right? Otherwise, you just sort the array. So now all the neighboring consecutive elements, they are neighbor to each other. You store a longer sequence which is 1 and the current sequence which is 1. So this longer sequence is the one that I was talking before, which is the max length you have seen so far. So you iterate the array from 1 all the way to the right. If they're duplicates, you just skip them, right? So for an example, in this case, when you see 1, 2, 2, 3, when you are at this 2, you check that this is equal to the previous element, so you just skip this element, you move the pointer to 3. When you come to the 3, you check, right? This is consecutive to 2, right? This 3. So you just increase the current sequence, which is 2. Here it is 2. So when you check 3 with 2, you increase your current sequence and it becomes 3, and you just update the current sequence, right? And if there is another case, which is case number 3, which is the same. When you see the gap, you just check, update the longer sequence and reset the current sequence to 1. And in the end, this is just the final case. So for an example, just to update the longer sequence in the end, for example, in this case, when you will be at this index, at that time your current sequence would be 4, right? And your longest sequence would still be 1, right? Because your longer sequence is only updated when you see a gap, but there is no gap in this case, right? So in the end, when you come out of this loop, you just check, basically you just return whatsoever is the longest, whatsoever is the maximum of current sequence and longest sequence, which is 4 in this case. So what do you think will be the time complexity in this case? You are just sorting the array and the sort is n log n, right? Then what you are doing, you are just iterating the array from left to right, which is of n, right? And so this is the time complexity in this case. And what is the space complexity? It's of n. You are not using any space in this, right? As long as this n log n is not using any space. And in Java, I think arrays.sort doesn't use space, so it's a constant time. And what else could you do better here? if you check, we could just skip this sorting part, which is taking most of our time in this approach, right? How? What's the intuition for the best solution? So basically, if you come here, you could just use the set. How? So basically, you can just dump all the numbers in the hash set so we can check if a number exists instantly or not, right? So let's say you are given this array again, right? So what's the intuition for this solution? So basically, you just need to check, you just need to treat this number as the starting element of the sequence. And to check if it's a starting element, you just have to check if the left neighbor of this number exists or not. Like for 100, the neighbor is 99. If 99 exists, this number could never be treated as the starting point of a sequence. You will keep on doing this for all the numbers. If there is a number for which the left number doesn't exist, for an example for 100 in this case, and similarly for 1 and 200, so it means these could be the starting sequences of the longest sequence, right? Now, when you find a valid start point, you just have to count upwards all the way until the sequence breaks, right? So how you are going to check if the left neighbor exists or not for these numbers? Basically, you have to first dump all the numbers in the hash set, right? We iterate through the set, but we only attempt to count a sequence if the current number is the start of the sequence. We know a number is the start if its left number neighbor, which is num minus 1, does not exist in the set. If the neighbor exists, we simply skip this number. This point is very important. If the number exists, we simply skip this number. For an example, in this case, when we come to 4, we check if 3 exists in the hash set or not. If it exists, so it means 4 is not the start of 4 is not the start of the sequence. So we just ignore 4. We don't need to check if there is any sequence that starts from 4 and is the longest, because we already know that there is a 3 before, and the longest sequence should must be starting from 3, not from 4. And similarly, when we check for 3, the longest sequence must be starting from 2 and not from 3. And similarly for 2, the longest sequence must be starting from 1, not from 2, right? So what will be the time complexity of this approach? If you check, we are just putting dumping all the numbers in the hash set, which takes of n time, and then we are just iterating all the numbers from left to right, right? Checking each number if it's the start point, and if it's a start point, we just check count upwards in a while loop until the sequence breaks. So this logic ensures we never recount the same sequence twice, keeping the total time complexity strictly to of n, which is here. All right. So what's the space complexity? Space complexity would be O of n, because we are dumping all the numbers in the hash set, and the total numbers could be n, right? If you check the logic, here is the code, Java code for your understanding. First, we just check if the nums is length is 0, then it means there is no consecutive sequence. We dump all the numbers in the hash set here, and then we just iterate through the set one by one. We check if this number, like the current number, is the start of the sequence. If num To check if num is the start of the sequence, we just have to check if the left neighbor of num, which is num minus 1, if it exists in the set or not. If it doesn't exist, then it means this number is the valid number that could start a sequence, right? Then what we do is we simply just count upwards until and unless we just see the next numbers. We just start counting. We just increase the counter here, and we just increase the number here. We keep on doing this until we found the next numbers in the sequence. And when the sequence breaks, then we just update the longest sequence here, and in the end we just return the longest sequence. Now I'll show you the code on the Leetcode, so that you could just check. So if you see here, this is the same code which I just mentioned. So this is the base case, which is just to return. This is the edge case, just to return zero in case the length is empty. Then we just dump all the elements in the set. Then we check all the numbers in the set, and we consider if the number could be the start of the sequence. If the number is the start of the sequence, we just count upwards until the sequence continues. And when the sequence breaks, we just check, we just update the longest sequence we have found so far, and then in the end, we just return the longest sequence. So if I submit this code, it will say the code is correct. I'll be posting all the other solutions for the Leetcode problems. I think this problem is part of Blind 75. I'll be posting some other videos of Blind 75 sheet also. So please subscribe if you like this video and if it's helpful for you. So please follow this channel. Thank you so much, guys.